Okay, Physics 30s, Mr. Thompson here. We're looking on page 121, quantum mechanics. We're going to solve some problems using de Broglie's equation and understanding that electrons do exhibit wave behavior and demonstrate the principle of diffraction. So let's take a look at these questions. We'll start with number one. It says, what is the wavelength of a 30-gram bullet that is moving at a speed of 500 kilometers per hour? Okay, so to solve the problem here, what we do is we use the equation for matter waves, which is the wavelength is h over mv. And so we'll have 6.63 e negative 34 joule seconds over the mass, which is 30 grams, so convert that to kilograms. And 500 kilometers per hour. Remember, 500 divided by 3.6 gives it in meters per second. Okay, and now the calculation. 1.59 times 10 to the negative 34, so we'll go with 1.6 e negative 34 meters. All right, part B. An electron that has 25 electron volts of kinetic energy. So if the kinetic energy is 1/2 mv squared, we can solve for the speed. 2ek over m under the square root and put in what we have here. We have 2 times, now we have 25 electron volts, so 25 times 1.6 e negative 19, because we need to convert this to joules. Okay, and then the mass of an electron and square rooting. All right, 2.96337 E, what do we have here? 36 meters per second. Now we can figure out the wavelength, h over mv. 6.63 e negative 34 divided by the mass and what we just determined. All right, I get 2.45, so we'll go to two significant digits, so 2.5 e negative 10 meters. So you can see here that an object that's larger, like a bullet, has a very tiny wavelength, which can't really be measured. But things like electrons, of course, this is about 2.5 angstroms, which is detectable. Okay, I'll do another problem. Just give me a minute.